Hello everyone, I am T. Ramesh, Assistant Professor, Department of Mathematics, Dr. S.N.S. Rajalakshmi College of Arts and Science, Coimbatore. In this case study video, we are going to discuss about the formulation of linear programming problem. Before that, what is linear programming problem? Linear means is a variable and its power is 1. So what is program? Program means planning. That means why it is linear. All the relationship between the variables consider these problems are linear. Hence the name is linear programming problem. The general form of linear programming problem is maximize or minimize z is equal to c1x1 plus c2x2 plus c3x3 plus etc. cnxn, and subject to the constraints a11x1, a12x2 plus etc. annxn either less than or greater than or equal to bn, and so on up to am1x1 plus am2x2 etc. amnxn either less than or greater or equal to some bm, and x1 x2 etc. xn all are greater than or equal to 0. That means all are positive. So here what's the purpose? The purpose of LPP is the problem to determine the value of the n variable x1, x2, etc. xn, which makes z as maximum or minimum as required in subject to the constraints and non-negativity conditions. In the before, the equation 1 is called objective function and equation 2 is called constraints, and equation 3 is called non-negativity restrictions or non-negativity conditions. Cj is a cost, and therefore that one is called a cost function. What are the formulation of LPP? How formulate this linear programming problem? We follow the 4 different steps. The one is identify the decision variable, that is x1, x2, etc. xn, and second one is write down the objective to be optimized. What is objective? It is maximized or minimized in the linear functions. And third one, the constraints. So note the constraints on the basis of the conditions specified regarding availability of time, demand for the product, etc. Step 4, they mention the non-negativity restrictions, which imply that the decision variables cannot be negative. That means the x1, x2, etc. xn all are positive. So we formulate the LPP. Here in this video we have discussed 2 different case studies. The case 1, the first formulation of LPP case 1. The first problem is a firm manufactures produced 2 types of product A and B and sells them at a profit of rupees 2 on type A and rupees 3 on type B. Each product is processed on 2 machines like M1 and M2. Type A machine requires 1 minute on processing time on M1 and type 2 requires 2 minutes on M2. Processing time of type B requires 1 minute of M1 and 1 minute of M2 machine. Machine 1 is available is not more than 6 hours 40 minutes, while machine 2 is available for 10 hours during any working day. Formulate the above as linear programming problem so as to maximize the profit. First, to understand that the problem is maximized, therefore the constraints are less than or equal to type. So how many variables are involved? Here there are 2 profit. One is there are 2 profits are given, therefore 2 decision variables involved. So let the firm decide to produce the x1 units of product A and the x2 units of product B to maximize its profit. Therefore, the decision variables are x1 and x2. So see this table here. Write first type A and type B. So the profit for type A is rupees 2 and the profit for type B is rupees 3. By this table, using this table, we have the profit of profit for A and B. Then the machine 1 and machine 2. Machine 1 type on A is so process time is 400 minutes. That means 400 minutes. So M1 is type A is 1, M1 type B is 1 is not exceeding the 400 minutes, and therefore to produce these units of type A and product B, it requires x1 plus x2 processing machines on M1 and 2x1 plus x2 processing on machine 2. So M2, the type A is 2, M2, the type B is 1. So it is the process time is not exceed 600 minutes. So since the machine M1 is available not more than 6 hours and 40 minutes and machine B is available for 10 hours during any working time is already given. Therefore, the constraints are x1 plus x2 less than or equal to 400 and the second one is 2x1 plus x2 less than or equal to 600. Both the decision variables are positive. So we formulate all this. Since the profit for type A is rupees 2 and the profit for type A is rupees 3, so total profit is 2x1 plus 3x2. So objective is optimum, that is optimum is maximum. Our objective is maximum functions, therefore maximum is 2x1 plus 3x2. Therefore the required LPP is maximum Z is equal to 2x1 plus 3x2 subject to the constraints x1 plus x2 less than or equal to 400, 2x1 plus x2 less than or equal to 600 and both variable x1 and x2 are positive greater than or equal to 0. That is formulation. Next we discuss another case problem on a company makes two types of the leather product A and B. Product A is high quality and product B is of lower quality. The respective profits for rupees A and rupees B per product, rupees 5 per product. Each product A requires twice as much time as product B and it all product were of type B. The company could make 1000 per day. A supply of leather is sufficient for only 800 product per day, both A and B combined. Product A requires has special spare parts and only 400 per day are available. There are only 700 special spare parts a day available for product B. So formulate this all as a LPP. So how formulate this? First we decide the company decide to produce x1 units of product A and x2 units of product B for what purpose? To maximize its profit. Therefore, the decision variables are x1 and x2. From this table, we have the conclude. First, we write type A and type B, leather and units. So, type A profit is rupees 4, type B profit is rupees 5. So, leather. So, we divide so many cases. Leather time, supply of leather, special spare parts for A and B combined. So, each product A requires twice as much time as product B. Therefore, type A is 2 minutes, type B to 1 minute. Therefore, it is 2x1 plus x2, which is not more than 1000 units. Therefore, it is less than or equal to 1000. The company could make 1000 per day. So, that purpose we make it is 2x1 plus x2 less than or equal to 1000. Next, the supply. The supply of leather is sufficient for only 800 product per day, both A and B combined. Therefore, if a product A, we have one supply. Similarly, product B is also one supply. Therefore, the leather is sufficient, not more than 800. Therefore, it is x1 plus x2 less than or equal to 800. Product A requires a special spare parts only. Therefore, put type A is 1 and 400. The special spare parts only 400 is available per day. Therefore, we have x1 is less than or equal to 400. Similarly, the product B requires special spare parts only for 700 available per day. Therefore, x2 is less than or equal to 700. So, profit is 4 rupees for A and 5 rupees for B. Therefore, 4x1 plus 5x2 is for cost functions. Therefore, company decided to produce the x1 units of type A, product A and x2 units of product B to maximize its cost. Therefore, the objective function is maximum Z is equal to 4x1 plus 5x2. So, therefore, we conclude the required LPP. Maximize it is 4x1 plus 5x2 subject to the constraints 2x1 plus x2 less than or equal to 1000, x1 plus x2 less than or equal to 800, x1 less than or equal to 400, x2 less than or equal to 700 and both x1 x2 are greater than or equal to 0. Thank you.